Hello all my dear students. I welcome you all to Sri Jendra Rank Zone classes and I am your mentor Amit Ajmani. Now students, I hope that you all are doing good, and in today's class we will be discussing about a new chapter, that is sound. Now we know that what exactly sound is. Sound is a form of energy which makes us hear. Now this sound is a wave motion which is produced by a vibrating source, and a medium is necessary for the propagation of a sound wave. Now what exactly are waves? We know that a wave is a vibratory disturbance in a medium which carries energy from one point to another without there being a direct contact between the 2 points. A wave is produced by the vibration of the particles of the medium through which it passes. Quite importantly, you need to relate that when a wave passes through a medium, the medium itself does not move along the direction of the wave. It's only the particles of the medium which vibrate about their fixed positions. Now there are different types of waves. Let us try to understand them one by one. Mechanical or elastic waves. The waves which can be produced in a material medium are called the elastic waves or the mechanical waves. So in other words, we can say that the mechanical waves require material medium for their propagation. Now, on the basis of vibrations of the particles of the medium, these waves are classified into further two types. One are the longitudinal waves and the other one are the transverse waves. Let us see first the longitudinal waves. A wave in which the particles of the medium vibrate back and forth in the same direction in which the wave is moving. Such type of wave is called a longitudinal wave. These longitudinal waves can be produced in all the three media, whether it is solids or liquids or gases. For example, the sound waves in air are longitudinal waves. Now these waves propagate in the form of alternative compression and rarefaction. What are these compression and rarefaction? A compression is that part of a longitudinal wave in which the particles of the medium are closer to one another as compared to their normal arrangement, and because of this there is a momentary reduction in the volume of the medium, due to which there is a temporary increase in the density of the medium. So we can also say that compression is a region of high pressure. Talking about rarefaction. Now what exactly is rarefaction? A rarefaction is that part of longitudinal wave in which the particles of the medium are farther apart than normal, because of which there is a momentary increase in the volume of the medium, and hence there is a temporary increase in the density of the medium. So we can, it should be decrease in the density of the medium. So we can say that rarefaction is a region of lower pressure. So these compression and rarefactions are formed in case of a longitudinal wave. A compression is a region of higher pressure and rarefaction is a region of low pressure. Now, graphically, we represent the longitudinal waves by a density distance graph. Quite important, you need to relate that the longitudinal waves are represented by a density distance graph. Let us see how. For example, we have just taken a graph like this, and this x is the line of this xy is a line of normal density. Now, when a wave motion is represented, then in that case, the region above this normal density is greater than the normal one, and it is called compression. Whereas below this, when the wave is going, these regions B and D, they show density which is less than the normal, and they are called rarefaction. Clear? So this is about longitudinal waves. Let us talk about the next type of waves, which are our transverse waves. Now what exactly are transverse waves? A wave in which the particles of the medium vibrate up and down at right angles to the direction in which the wave is moving. Such type of wave is called a transverse wave. Now these transverse waves can be produced only in solids and on the surface of liquids, but not in gases. For example, when we just move the one end of a long spring, which is also called slinky, up and down rapidly, then the waves produced are transverse waves. Now this slinky has one end fixed, and when we are moving it up and down, the same case we see in the case of water waves or the ripples which are formed on the surface of water in a pond. The light waves and the radio waves are all transverse waves. Now these transverse waves propagate in the form of crests and troughs. Now what are these crests and troughs? The elevation or hump in a transverse wave is called crest. In other words, we can say that a crest is that part of the transverse wave which is above the line of zero disturbance of the medium, whereas the troughs are the depression or hollow in a transverse wave. In other words, we can say that a trough is that part of the transverse wave which is below the line of zero disturbance. Now, when we graphically represent a transverse wave, they are represented by a displacement distance graph. I hope you are able to relate the difference between the longitudinal waves and the transverse wave. In longitudinal waves, the motion of the particle was back and forth, whereas in transverse wave, the motion of the particle is up and down at right angles. This is the first difference. Second quite important difference is that in longitudinal waves, we have compression and rarefaction, whereas in transverse waves, we have crest and troughs. The third difference is that a longitudinal wave is represented by density distance graph, whereas a transverse wave is represented by displacement distance graph. Just try to relate graphically. Now, this is a graph in which we have taken this x and y to be the line of zero disturbance, and there is any displacement above or below the line of zero disturbance. They are called crest and trough respectively. The crest shows the positive displacement, that is above the line of zero displacement, and the trough are the negative displacement, that is below the line of zero disturbance. This is a displacement distance graph through which we are representing a transverse wave. Let us try to see the difference between the longitudinal and the transverse waves that we have just seen above. The particles of medium, in case of longitudinal waves, they move back and forth in the same direction to the direction of wave, whereas in case of transverse waves, the particles of medium vibrate up and down at right angles to the direction of wave. The longitudinal waves can travel in solids, liquids as well as gases, but they cannot travel through vacuum, whereas the transverse waves can travel in solids and liquids only, and they can also travel through vacuum. The longitudinal waves are also called mechanical waves, whereas the transverse waves are also called electromagnetic waves. The speed of longitudinal waves is very low, whereas the speed of transverse wave is quite high. The sound waves are an example of longitudinal waves, whereas the light waves are an example of transverse waves. So these are the types of waves, correct? Now let us try to understand the various characteristics of a sound wave. The first quite important characteristic is wavelength. Now what exactly is meant by wavelength? It is the minimum distance in which a sound wave repeats itself. That is called the wavelength. We can also say that wavelength is the length of one complete wave. This wavelength is denoted by this Greek letter, this lambda, which is expressed as just reverse y. Now, in a sound wave, the combined length of a compression and a rarefaction can be called its wavelength, right? Now, if we take the distance between the centers of a compression and an adjacent rarefaction, that will be equal to half of the wavelength. And the SI unit of wavelength is meter. Let us try to understand it with the help of this particular figure. In this, we have made a wave. Now, if we relate from A to D, this is one compression, and from D to G is one rarefaction. After G, the wave is repeating itself, right? So, the distance from A to G is called wavelength. We can also relate in the figure that the distance from B to H can also be called the wavelength, or from C to I can also be called the wavelength, right? From D to J can also be called the wavelength. These are all the wavelengths. Fine. Now the second important characteristic of a sound wave is the amplitude. What exactly is an amplitude? It is the maximum displacement of the particles of the medium from their original undisturbed positions when a wave passes through the medium. So that maximum displacement is called the amplitude of the wave. And this amplitude is usually denoted by the capital alphabet A, and the SI unit of the measurement of amplitude is also meter. In this particular graph, if we try to relate the amplitude, then from B to C, this is the amplitude. Similarly, from E to F, this is the amplitude. And they are always equal. BC is equal to EF because the wave is going to displace on both sides equal distances. Got it? Coming to the next characteristic, that is the time period. Now what exactly is time period? It is the time required to produce one complete wave or one complete cycle. That is called the time period of the wave, or it is the time taken to complete one vibration. That is called the time period of the wave. Now this time period is denoted by small alphabet t, and the SI unit of time period is, of course, second. The next characteristic is the frequency, quite important. What is the frequency? It is the number of complete waves or the number of complete cycles which are produced in 1 second. That is called the frequency of the wave. We can also define the frequency as the number of vibrations per second. Now, this frequency of a wave is always fixed and does not change even when it passes through different substances. This frequency is represented by F, or it is nu. The SI unit of frequency is hertz, which is written as capital H small z, and 1 hertz is equal to 1 vibration per second. Now this frequency is the opposite of time period. So if we try to relate the relation between time period and frequency of a wave, we see that frequency of a wave is the reciprocal of its time period. So we can say that F is equal to 1 by T, where F is the frequency of the wave and T is the time period of the wave. So these are the 4 very important characteristics of a wave that we have just studied. First is the wavelength, then we talked about the amplitude, third we talked about the time period, and next is the frequency. Try to keep all these in mind, right? Now let's talk about the velocity of a wave. How will you relate it? It is the distance traveled by a wave in 1 second is called the velocity or the speed of the wave. This velocity is represented by small letter v, and the SI unit for measuring the velocity of wave is same as that of measuring the velocity of any other body, which is meters per second, right? Now you need to relate this quite important wave equation. We know that the formula for calculating velocity is distance or displacement divided by time taken. This velocity we are representing with v. The distance traveled by a wave is in the form of wavelength, which is represented by lambda and divided by time taken. Now we can also write this equation as velocity is equal to lambda into 1 by t, and we have just seen above that 1 by t is called the frequency. So replacing the value of 1 by t with frequency, we can write velocity is equal to frequency into wavelength. V is equal to F into lambda, where V is the velocity of the wave, SI unit is meter per second, frequency F, SI unit is hertz, and lambda is wavelength, SI unit is meters. This equation is called the wave equation. And this wave equation says that the velocity or speed of a wave in a medium is equal to the product of its frequency and wavelength, right? So this formula V is equal to F into lambda is called the wave equation, and this wave equation implies all types of waves, whether it is the transverse waves like the water waves, or the longitudinal waves like the sound waves, and the electromagnetic waves like the light waves and radio waves. Clear? So this is all about our waves. Now we'll discuss about how sound is produced. Now sound can be produced by either of the following four methods. First is by vibrating strings we can produce sound, as we have seen in the case of musical instruments like sitar or guitar. The second way of producing sound is by vibrating air, as we do in a flute or a mouth organ. The third way of producing sound is by vibrating membranes, as in the drums or the congos or the tabla. And the fourth way of producing sound is by vibrating plates, as in a bicycle bell. So these are the four ways through which we can produce sound. Got it? Now talking about the speed of sound. The speed of sound is different in different mediums, and the speed of sound depends on the nature of the material or the nature of the medium through which it travels. It also depends on elastic density and temperature of medium. For example, quite important, you need to learn it, that at room temperature the speed of sound in air is 344 meter per second. But when we talk about the speed of sound in water, it is about 1500 meter per second, and the speed of sound in iron is 1530 meter per second, right? So from the above values, in general way we can conclude that the sound travels the slowest in gases, faster in liquids, and fastest in solids. And that is the main reason why the density of dry air, because it is more than that of moist air, therefore in moist air the speed of sound is more than the dry air, because in moist air the moisture, that is the humidity, that is the water vapors, that is the liquids are present, in which the speed of sound is faster as compared to that of air. Now, one more important thing is that if the medium in which sound is traveling has its own speed, in that case the speed of sound increases in the same direction and decreases in the opposite direction. So these are a few points we need to relate regarding the speed of sound. Now there are various factors which affect the speed of sound. What are these? The first factor is temperature. The speed of sound is directly proportional to temperature, which means that on increasing temperature, the speed of sound will also increase. For example, if we see the speed of sound in air at a temperature of 0 degrees Celsius, it is 332 meter per second. But the speed of sound in air at a temperature of 20 degrees Celsius is 344 meter per second. So we can see that on increasing the temperature, the speed of sound has also increased. So they are in direct proportion to each other. On increasing the temperature, the speed of sound also increases. That means the speed of sound in air will be more on a hot day as compared to the speed of sound on a cold day. So this was the first factor on which speed of sound depends. The second factor is humidity. The speed of sound is again directly proportional to the humidity. The speed of sound is less in dry air, as we have seen above, as compared to that of humid air. Why? Because as the humidity of air increases, the speed of sound through it also increases, being in direct proportion with that. The next factor on which the speed of sound depends is the nature of material or the nature of medium. We have just seen above that the sound travels slowest in air or gases, faster in liquids or water, and fastest in solids. We have seen the values of the speed of sound in air is 344 meter per second at room temperature. But in water, it is almost 3 times, rather 4.5 times, that is 1500 meter per second. And in iron, it is the maximum 5130 meter per second. Right? So these are the three factors on which the speed of sound depends. Right? The first factor we have seen is the temperature, second is the humidity, and third is the nature of the medium. Now you need to relate a few points. The first point is the term supersonic. Supersonic refers to the speed of an object which is greater than the speed of sound. When a supersonic body or a plane travels in air, it produces energetic disturbance which moves in the backward direction and diverges in the form alone. Such disturbances are called shock waves. And the tremendous air pressure variations caused by the shock waves produce a loud burst of sound which is called sonic boom. This sonic boom is an explosive noise which is caused by the shock waves from an aircraft or any object which is traveling at the speed faster than the speed of sound. So we need to know what is meant by supersonic, what are the shock waves, and what is sonic boom. Clear to all? Now let us try to relate the reflection of sound. What is meant by reflection? We have studied earlier. We have studied about the reflection of light till now. But reflection means the bouncing back. The bouncing back is called reflection, and because we are talking about the reflection of sound, It means the bouncing back of sound when it strikes a hard surface. We have studied about the laws of reflection of light. There were two laws governing the reflection of light. Both these laws also hold good in case of sound waves also. So what are the laws of reflection of sound? Just like that of laws of reflection of light, that the incident sound wave, the reflected sound wave, and the normal at the point of incidence all lie in the same plane. Second law is the angle of reflection of sound is always equal to the angle of incidence of sound. Now the sound waves can also bounce back, they also reflect, and this phenomena, this property is used in various applications. Let us see where all the reflection of sound is applied. First is the case of megaphone. Now this megaphone is a large cone-shaped or funnel-shaped device for amplifying and directing the voice of a person who speaks into it. And this megaphone works on the principle of multiple reflection of sound. Similarly, the reflection of sound is used in case of bulb horn. Now what is a bulb horn? A bulb horn is a cone-shaped wind instrument which is used for signaling in bicycles or cars or buses or trucks and even the boats. This bulb horn consists of a cone-shaped bent metal tube having a hollow rubber bulb at its narrow end. And this bulb horn also works on the phenomena of multiple reflection of sound. The third application is in stethoscopes. Now these stethoscopes are the medical instruments which are used by the doctors for listening to the sounds produced within the human body, mainly in the heart and the lungs. Now these sounds of the heartbeats or the lungs, they reach the doctor's ears by again due to the multiple reflections of sound waves which take place through the stethoscope tube. So we can say that this stethoscope also works on the principle of multiple reflection of sound. This property is also used in the form of sound boards. The sound board is a concave board or a curved board which is placed behind the speaker in large halls or auditoriums. Why so? It is done so that the speaker's speech can be heard easily even by the persons sitting at a considerable distance. And these soundboards also work on the multiple reflections of sound. You must have noticed that the ceilings of the concert halls or the conference halls and even in the cinema halls, they are made curved. Why they are done so? They are done for purpose. They are made curved so that sound after reflection from the ceiling reaches all the parts of the hall. Why? Because this curved ceiling acts like a large concave soundboard and it is going to reflect the sound down onto the audience in the hall. So these are the various applications of the reflection of sound. Let us try to understand the concept of echo now. What is echo? It is the repetition of sound which is caused by the reflection of sound waves. So we can say that echo is simply a reflected sound. Now, one of the characteristic of our human ear is that we can hear two sounds separately only if there is a time interval of 1 by 10th of a second or more than that between the two sounds, right? And if our own sound is reflected and it comes back to us after this time gap of 1/10 of a second, we are going to just listen to our own sound again, and this is what is called echo. And the minimum distance from a sound reflecting surface, which may be a wall or anything, in order to hear an echo is 17.2 meters at 20 degrees Celsius. What do you mean by saying this? This means that in order to hear an echo of our shout or of our own sound, we should be at least 7.2 meters away from a sound reflecting surface like a wall. Now we know that the speed of sound is more on a hot day. In that case, an echo is heard sooner on a hot day as compared to that of a cold day. When it is lightning in the sky, the rolling of thunder that we hear, it is due to multiple reflections of sound only, because of the thunder from a number of reflecting surfaces such as the clouds and the land. Clear? Now in air, if we talk about, then for hearing echo, the distance must be 17.2 meters. But when we talk about the underwater scenario, then the minimum distance of a diver from an underwater rock to hear the echo of his own shout will be 75 meters, because the speed of sound there is 1500 meter per second, right? Now this reflecting sound waves, this echo leads to one other phenomena which is called reverberation. What do you mean by reverberation? It is the persistence of sound in any big hall due to repeated reflections from the walls or the ceilings or the floors of the hall. So that persistence of sound, that overlapping of sound is called reverberation. Now if the reverberation is too long, then the sound becomes blurred, it becomes distorted, it becomes confusing. Why? Because the different sounds are overlapping with each other. So we tend to stop or reduce this reverberation, especially in big halls and auditoriums. And for that, we use various following methods. Number one, in order to reduce the reverberations, the panel made of sound absorbing materials like compressed fiberboard or felt are put on the walls and ceilings of the big halls and auditoriums because they help to reduce the reverberations. Next way of reducing reverberation is putting carpets on the floor because they also absorb sound, due to which they also help in reducing the reverberation. Another way is to put heavy curtains on the doors and windows. So on doors and windows, we put heavy curtains which also absorb sound and thus reduce reverberation. And when we are talking about halls or auditoriums, then the material having sound absorbing properties like soft and porous materials. Such kind of materials are used for making the seats in the big halls or auditoriums because they are made up of sound absorbing properties. They will reduce reverberation. Also because they are bad reflectors of sound apart from being good absorbers of sound. So these are a few ways in which we can reduce the reverberation in the halls or auditoriums. Clear? So this is about reverberations. Next, let's come to audible sound. The range of frequency from 20 Hz to 20,000 Hz. This is the audible sound. This is the frequency range of hearing in humans. So the sound which we are able to hear, that is called audible sound, and we are able to hear any sound which lies between this frequency range of 20 Hz to 20,000 Hz. Any sound whose frequency is lower than 20,000 Hz, they are called infrasonic sounds or simply infrasound, which means that these infrasonic or infrasounds are very low frequency sounds, and because they are quite less as compared to our audible frequency range, that is why humans cannot hear the infrasonic sounds. Now the sound of frequencies higher than the upper range of our frequency, that is if it is higher than 20,000 Hz, they are known as ultrasonic sounds or just ultrasound. These ultrasonic sounds are very high frequency sounds, and even they cannot be heard by human beings because they are above the frequency range of the audible sound. But few animals, they have few features like dogs. They can hear ultrasonic sounds of frequency up to 50,000 Hz, which is much more as compared to us humans. Bats are even better. They can hear ultrasonic sounds having frequency up to 1,20,000 Hz. Clear? Now these ultrasonic sounds have very high frequency, because of which they have a much greater penetrating power than ordinary sounds. And because of this, these ultrasounds have various applications in various fields. Let us see where all these ultrasonic waves or ultrasounds can be used. Let us try to relate them one by one. This ultrasound is used in industry for detecting flaws or cracks, etc. in metal blocks without damaging them. Second use of ultrasound is that they are used in industry to clean hard to reach parts of the objects such as the spiral tubes or any odd shaped machines or the electronic components. Quite important use is this ultrasound is used to investigate the internal organs of the human body, such as the liver or gallbladder or pancreas or kidney or uterus or even heart. There is a technique in which we obtain pictures of the internal organs of the body by using echoes of ultrasound pulses. That technique is called ultrasonography. This is very important technique because it helps the doctors in the detection of stones in the gallbladder or kidneys, or to check out for tumors in different organs and many other ailments. When we use these ultrasound waves to investigate the action of the heart, that is called echocardiography. So ultrasound has many uses in the medical field. Let us see the another use. Ultrasound scans are used to monitor the development of fetus, that is the unborn baby inside the mother's uterus. Ultrasonography is used for this purpose in order to examine the fetus, that is the unborn baby, during pregnancy so as to detect if there is any growth abnormalities. Next use of ultrasound is that ultrasound is used to break the kidney stones into fine grains, which then get flushed out with urine. So any person having kidney stones, ultrasound can help. Next is ultrasound is used in sonar apparatus for many purposes like to measure the depth of the sea or ocean, or to locate the undersea objects like the shoal of fish or the shipwrecks or the submarines or the sea rocks or any hidden iceberg in the sea. How? We will just try to understand, but before that try to brush up the uses of ultrasound once again. These ultrasounds are used in various fields for detecting the cracks or flaws in the metal blocks, for cleaning the hard to reach parts, for investigating the internal organs by the techniques called ultrasonography and echocardiography. Next, to check the development of the fetus during pregnancy and to break the kidney stones and in sonar. So these are very vital applications of ultrasound. Now let us try to study in detail what sonar is. This word sonar refers to sound navigation and ranging. This is the full form of sonar. Actually, this sonar is an apparatus or a device we can say which is used to find the depth of a sea or to locate the underwater things like shoals of fish, shipwrecks, and enemy submarines. How does it do it? This sonar apparatus consists of two parts. One is a transmitter, which is used for emitting the ultrasonic waves, and the second part is a receiver, which is used for detecting the ultrasonic waves. Now, how sonar works? A pulse of very high frequency of about 50,000 Hz is emitted. Now, this pulse will travel down the sea water towards the bottom of the sea, and once it strikes the bottom of the sea, it is going to reflect back to the ship in the form of an echo. Now, this echo produces an electric signal in the second part, that is the receiver part of the sonar device, which then measures the time taken by the ultrasonic sound pulse, that how much time it has taken to travel the whole distance both sides. Now once we know this time taken by the ultrasound, then we just try to calculate by using the speed of sound in water. We will calculate the distance, that is we will be able to relate what is the depth of the sea. Got it? So this is how sonar works. Now this sonar uses ultrasound waves or the ultrasonic sound waves because of its advantages. What are these advantages? Number one advantage of ultrasound sound waves as compared to the ordinary sound waves is that these ultrasonic sound waves have a very high frequency and a very short wavelength, due to which they have got a high penetrating power and they can penetrate into the seawater to a large extent. The second reason why ultrasonic sound waves are advantageous is that these ultrasonic sound waves cannot be confused with any kind of engine noises or other sounds made by the ship. Why? Because simply their frequency is so high, so they cannot be heard by the human beings. So these are the various advantages of using ultrasonic sound waves in the sonar apparatus, right? So these are the various applications of ultrasonic waves and all about sonar. Now let us talk about a very important topic which usually comes in exam in one form or the another, that is characteristics of sound waves. There are various characteristics of sound waves. What are these? The first characteristic is loudness. Loudness is the measure of sound energy reaching the ear per second, and this loudness depends on the amplitude of sound waves. The sound waves which have small amplitude will be faint or soft sounds, whereas the sound waves having large amplitude will be loud. So we can say that greater the amplitude of the sound waves, louder the sound will be. This loudness is measured in decibel, very importantly written as small d and capital B. And the softest sound which a human ear can hear is said to have a loudness of 0 decibel. Clear? So this is the first characteristic of a sound wave. The second characteristic of a sound wave is the pitch. What is pitch? Pitch is that characteristic of sound by which we can distinguish between different sounds of the same loudness. Clear? Now this pitch of sound wave depends on frequency of vibrations. This pitch is directly proportional to its frequency. For example, the sounds of low frequency are low pitch sounds, whereas the sounds of high frequency have high pitch. So faster the vibrations of the sound producing source, the higher its frequency and therefore the higher is the pitch. Let us come to the third characteristic, which is quality. Quality is also known as timbre. Now this timbre is that characteristic of musical sound which enables us to distinguish between the sounds of same pitch, same loudness, but they are produced by different musical instruments and different singers. Now the quality or timbre of a musical sound depends on the shape of sound waves or the waveform produced by it. Clear? Now very important, these are the three characteristics of sound waves that we have studied. First is the loudness, second is the pitch, and third is the quality. First of all, you need to relate what loudness is, what pitch is, and what quality is. And very importantly, we need to state and learn on what factor loudness or pitch or quality depends on. Loudness depends on the amplitude of sound waves, right? Higher the amplitude, louder will be the sound. Pitch depends on the frequency of sound waves or the vibrations. Higher the frequency, higher will be the pitch. And the quality depends on the shape of the sound waves or the waveform, right? The sounds may be from different sources having the same loudness and the same pitch, but still we can make out the difference between the sounds because of its quality. So these are the characteristics of sound waves, and this is all about our chapter sound. I hope you must have been able to relate it, you must have been able to understand, and obviously in the next class, because we'll be discussing the question answers of sound, I want you people to make sure to read it, understand it, and learn it. I always want that everybody of you should be prepared with all the topics when we are having a discussion class regarding the questions related to a particular chapter which are important and which have come in the examination. And the whole purpose is once you are prepared, you will be able to participate better. You will be able to just confirm and ensure that what exactly is your preparation level, how far you were right when you said that yes sir, sound chapter we learnt. It is only when you are assessed that we will get to know how much prepared you are. Got it? So next class, question answers of sound, read it, learn it, and come prepared for the next class. So ending this class here only. We'll meet you in the next class. Till then, take care of yourself, guys, and have a great time. Thank you so much for being with me. Goodbye, everyone.